Okay, in this video I'm going to solve the problems in your mini test section 1.5, 1.5, 6, and 7. The first question is y is equal to negative 5 times x minus 1 squared plus 4 and y equal to 2. We have to solve this system of linear quadratic equations. Since both of them are equal to 1, equal to y, we can say that they are equal. So from here, I can write that negative 5 x minus 1 squared plus 4 is equal to 2. Now I'm going to bring 4 to the right. I get negative 5 x minus 1 squared is 2 minus 4, which is negative 2. I divide both sides by negative 5 to isolate x. This goes with this one, so I get x minus 1 squared is equal to 2 over 5. The opposite of square is square root, so I take the square root of both sides. But remember, when you take the square root of 2 over 5, it's going to be plus or minus. Square root of x minus 1 squared is x minus 1. Is plus or minus square root of 2 over 5. I'm going to move negative 1 to the right. I get x is 1 plus or minus square root of 2 over 5. Now, since we have to find the coordinate of point of intersections, we know that the x coordinates are 1 plus square root of 2 over 5 and 1 minus square root of 2 over 5. So we know that the coordinates are going to be 1 plus square root of 2 over 5. And the y coordinate, I can either substitute this value in either one of these two equations. But the easiest one is just y equal to 2. We know that 2 points, they are going to have the same y coordinates, which is 2. And the next one is going to be 1 minus square root of 2 over 5 and 2. You can also substitute these two values inside this equation and you're going to get the value 2. Doesn't matter. The next question is to write the equation for the family of quadratic functions in standard form with zeros or roots at negative 7 plus square root of 2 and negative 7 minus square root of 2. If you remember from the class, we said that a quadratic in x-intercept form or factored form is y is equal to a times x minus r times x minus s, where r and s are the zeros or the roots. So I can write, for this case, is a x minus the first root, which is negative 7 plus square root of 2 times x minus negative 7 minus square root of 2. Now I'm going to distribute this negative inside the bracket here too. So I get a times x. Now negative times negative 7 gives me plus 7. Negative times square root of 2 gives me negative square root of 2. Negative times negative 7 gives me 7. Negative times negative square root of 2 gives me plus square root of 2. Now, if you remember from grade 10 academic, we used to have this identity that a minus b times a plus b, if you distribute this one, is going to simplify to a squared minus b squared, difference of squares. In this case, if you look at this one, x plus 7 and x plus 7 is repeating, and then you have square root of 2, square root of 2, and one is negative, the other one is positive. So this one can be written as a times x plus 7 squared minus square root of 2 squared, which is 2, which is a times x squared plus 49 plus 14x. If I expand this one, I get these three, minus 2, which is a times x squared plus 14x plus 47. Now if I distribute this one inside the bracket, because I have to express it in standard form, I'm going to get ax squared plus 14ax plus 47a. So this is the answer. In the third question, we have to use discriminant in order to determine the number of zeros and also the nature of roots, either they are real or imaginary. For the part A, we know that A is 2, B is negative 4, and C is equal to 7. D is B squared minus 4AC, which is negative 4 squared minus 4 times 2 times 7. Negative 4 squared is 16 minus 4 times 2 is 8 times 7 is 56. This gives us negative 40, which is less than 0. So we say that the number of roots is 0, no roots. In fact, no real roots, but there is going to be imaginary roots. So the nature is imaginary. Imaginary roots. In the next case, we have A is equal to 3, B is equal to negative 2, C is equal to negative 9. So D is B squared, negative 2 squared, minus 4, A is 3 times C is negative 9. Now negative 2 squared is going to give us 4. And negative 4 times 3 gives you negative 12 times negative 9 is going to give you plus 108. If you add it, it's going to be 112 greater than 0. Then we have 2 real roots. So the nature is real. The previous one, the nature was imaginary. In the next example, we are supposed to find the exact value. When it says exact value, just remember, if you get to a fraction or radical, do not use your calculator. Just leave it the way it is. After, you can simplify it. So, the first thing we're going to do is we're going to find the D. D is B squared, which is 3 squared, minus 4 times A, negative 1 over 2 times C, which is 6. 3 squared is 9. 4 times negative 1 over 2 gives you negative 2 times 6 is negative 12, but there is a negative here, so it's going to be plus 12. So this one is going to give us 21 greater than 0, so we know 2 real roots. Then we say that x1 and 2 roots are minus b plus or minus square root of d, which is 21 over 2a, 2 times negative 1 over 2. This simplifies to negative 3 plus or minus square root of 21 over negative 1 over 2 times 2 gives you negative 1. Now if I multiply the numerator and denominator by negative 1, negative 1 times negative 3 gives me 3. And when you multiply negative by plus or minus, it becomes negative plus. It just flips. And then square root of 21 over negative 1 times negative 1 is going to give you 1, so I'm not going to write it. So the answer is 3 negative plus square root of 1, 21. And you cannot simplify square root of 21 because 21 is 3 times 7, and both of them are prime numbers. The next example, we have to write the equation of a quadratic if the x-intercepts are 0 and 2 and it goes through the point 1 and negative 1. We know that in general, if the quadratic is given by the equation in the factor form, by equation a times x minus r times x minus s, where r and s are x-intercepts. So in this case, it becomes x minus 0 times x minus 2, which is ax times x minus 2 because x minus 0 is x. To find a, we know that it has to go through the point 1 and negative 1. So we say negative 1 for y is a times x is 1, 1 minus 2. A times 1 gives you a, 1 minus 2 gives you negative 1, so the answer is negative a. I divide by negative 1, and from here I get a is equal to 1. So my equation becomes x times x minus 2, because a is 1. The next example, we have to find the y-intercept of the line with the slope of negative 11 that is tangent to the quadratic 5 over 20 x squared plus 9x plus 6. We remember from grade 9 that the equation of the line in general is y equal mx plus b, where m is the slope and b is the y-intercept. We know the slope of the line is negative 11, so we say y is negative 11x plus b. Now we know that this line is tangent to this curve. Tangent means there is only one point of intersection. If you look at this quadratic, because the leading coefficient is positive 5 over 20, so it opens up. Now the slope is negative 11, so this means that the line is going to be something like this one, and this is one point of intersection. Now, to find the point of intersection, we are going to solve these two together, so I'm going to say 5 over 20 x squared plus 9x plus 6 is negative 11x plus b. I'm going to move these two to the left. I get 5 over 20 x squared plus 9x plus 6 plus 11x minus b is equal to 0. I group them together. I get 5 over 20 x squared. 9x plus 11x is 20x plus 6 minus b is equal to 0. Now, if you look at this one, a is 5 over 20, b is 20, and c is 6 minus b. Since it's tangent, we know that the d, which is b squared minus 4ac, has to be equal to 0 because there is only one point of intersection. So this means b squared means 20 squared minus 4a is 5 over 20 times c. c is 6 minus b, has to be equal to 0. 20 squared is going to give me 400. 4 times 5 is 20 over 20 is 1, so I get minus b plus minus 6, sorry, because this is 6, plus b. This is minus b, and there is a minus here, so if I distribute it inside, I get minus 6 plus b is equal to 0. Now, from here, I know that 400 minus 6 is 394. So if I move 394 to the right, I get b is negative 394. So this means the y-intercept of the line is negative 394. The last question of your mini-test was a flower garden which one side, which is this side, is covered by the house, but the other three sides are free. If we have 192 meters of fencing, what length, let's say this length is A, automatically this is A and this is B. What values for A and B gives the area of this flower garden to be maximized? So, the first thing is that we know that the perimeter or the amount of fencing we have is 192, which is equal to A plus B is 192. Which is equal to 2a plus b. That's the first equation. The second equation that we have to solve is to maximize a area, which is a times b, length times width. Now, to solve this one, you have two equations, two unknowns. We can solve it easily. So from here, I'm going to find that b is 192 minus 2a when I move 2a to the left. and then I substitute b back here, so I get a is a times 192 minus 2a. This one, if I distribute this inside, I'm going to get 192a minus 2a squared, which is the same as negative 2a squared plus 192a. Now, I want to maximize a. This means that I have to find the vertex of this equation. A is equal to negative 2a squared plus 192a. Just to remind you, this is a quadratic, and the leading coefficient, which is negative 2 over a, is negative, so the parabola opens downward, so the vertex is maximal. And this is exactly what we want, maximum area. Now we are going to use the shortcut to find the a coordinate of the vertex, so we're going to say VA is minus b over 2a. Now in this equation, b is this guy, which is 192, so negative 192 over 2a. A is the leading coefficient, which is negative 2, so I'm going to get negative 192 over negative 4, which is 48. Now to find the value for b, I'm going to use this equation. I'm going to say b is 192 minus 2 times 48, which is going to give me 96. So this means that if I have a rectangle, this to be 48, this to be 48, and this to be 96, is going to give me an area which is the maximum.